Hey y'all, it's Kelsey. So I decided to do my second screencast over the resistance to transgenic cotton in the bollworm. I have some notes here that I'm going to be reading off of too, so just stick with me. Um, First off, the work that I got my information from was from a field test done in the state of Arizona. So all the results that are from my screencast will be from those in Arizona. First, in Snow's article, it was talked about the risk of GEOs, and some of those are that they may be more vigorous pests and pathogens could be created, make the effects of existing pests worse through hybridization and breeding with transgenic organisms. It could cause harm to non-pest species, and there could be irreplaceable changes or loss in species genetic diversity. So the ESA, or Ecological Society of America, has a few recommendations, and those are that the GMOs be designed to reduce environmental risk. More studies of benefits and risk are needed. The effects evaluated should be based on a scenario. Release of GEOs should be prevented if there's knowledge about risks that is inadequate. Post-release monitoring needed, and all transgenic organisms are subject to assessment. So the crop plants with transgenic resistance to lepidopteran pests, the BT cotton falls in this topic. So one of the benefits would be to reduce the use of broad spectrum insecticides, and one of the risks would be that they're not sustainable if secondary pests become more problematic and target pests evolve resistance. Broad spectrum insecticides may delayed resistance to transgenic cotton in the pink bollworm. So the goal was to reduce reliance on insecticides. Cotton and corn have been genetically engineered to produce proteins from Bacillus thuringiensis that kills some key insect pests. First grown on a large scale in 1996, transgenic BT crops covered more than 20 million hectares worldwide in 2004. Rapid evolution of resistance by target pests is considered the primary threat to their continued success. In particular, worst-case scenarios yielded predictions that pests would evolve resistance to BT crops in as little as 3 years. So these results are from a long-term study of resistance to BT cotton in populations of pink bollworms across the state of Arizona. Pink bollworm is a lepidopteran pest with intense selection for resistance, and the larvae feed exclusively on cotton. So if the cotton is producing these toxins that the larvae are eaten, there's a really good chance that they will die, and they actually have nearly 100% chance of dying if they eat it. They also got some unexpected numbers. The unexpectedly high frequency of resistance detected from a laboratory selection in 1997, which was the second year of BT cotton. But there wasn't no net increase of rapid evolution of pest resistance from 97 till 2004. So the 3 years that they gave for the numbers to increase didn't. They had no net increase. Similar tests in subsequent years had no resistant strains from Arizona. Field tests comparing BT and non-BT cotton shows that BT cotton has more than 99% intended results, and no cases of reduced efficiency has been recorded. Long-term defeat of pink bollworm with no expectation of resistance increase has occurred with high use rate of BT cotton. So the synthesis of results. Although pink bollworm's response to BT cotton in Arizona is one of the most closely monitored, evidence from other pests in other regions also indicates